Oh. Alright, guys. Anyways, as I was saying just now, I'm going to be highlighting a few of the questions that I think are worth highlighting here. It's basically about what we did last week in the test. Starting off with the first question here, I think most of you guys got this correct. Some of you guys may have gotten question number 2 wrong. This is purely due to the fact that students are very sensitive with the numbers. When they see the number, they somewhat remember the formula and they straight away plug everything into the calculator. But they will never notice the units, guys. This here is measured in kilopascals. Then your answer should naturally be in kilopascals as well. I think most of you guys got this correct as long as you saw the units behind. But for those who just saw the 140 and then they scanned through this, they saw 140 and they circled this up already. Congratulations, you lost yourself one. Okay, so it's supposed to be kPa. This one, everyone, I think most of you guys got it correct, right? And the second one that I wanted to highlight was question number 5 here, guys. If you look at this question here, most of you guys didn't notice this. I think most of you guys might have circled C as the answer as well, guys. If you look at the question here, it says that the handle of the metal sauce pan is made of plastic, guys. This is the key word, And if it is made of plastic, will there be any free electrons or not? Definitely not, guys. The general rule in terms of conduction is that if it is metal, it has free moving electrons. The free moving electrons will be the one that pass on energy and obviously vibrate and go from hot to cold end, right? But if it is plastic, guys, you should just mention that they are vibrating and passing on energy to the adjacent molecules, guys. So C is definitely not the answer here, guys. You should say that the molecules of the plastic vibrate more and pass their energy to nearby molecules. If this was metal, then yes, C would have been the answer. The free electrons will be the one that transfer the energy. But because this is not a metal, it's plastic, then naturally B should be the answer here. I think most of you guys circled this question. If not half of you guys have circled this question wrong. The other class also half of them did the same mistake.
Who's the highest one?
Who was the highest one? I think Chi Jung got the highest.
How much?
90多.
Wow.
90多. But last test 他已经90多了 please. But this time the twin brother did very well. So Hao Zheng 上一次 I think almost failed the paper. 好像40多分这样子。这次他拿80多分。He studied very hard, man. Very good. 很开心。
I also.
You need to work harder. But good job on your improvement. Some improvement is better. Okay, then after that, question number 7. This one, you see, this one is the one with the metal, right? The copper one, right? Then you must mention the free electrons, right? And collide, move towards the other end. Yeah, this one for sure is C. Okay, and then how do you get question number 8 wrong? Oh, this one. Yes. Yeah. Okay, guys, if you have any other questions, please let me know to highlight it. If not, I'm just going to move on. Anyone else has any questions from question 1 to 8? I think the ones worth highlighting, I already mentioned it already. Oh, and for Evan, your case, I saw your paper. Almost all the calculations you did wrong, especially for the ABC. You better write down some working for your calculations next time. Okay, then after that, I think most of you guys, if not 100% of you guys got this question correct. I do want to highlight this one thing here, which some of you guys may have gotten it wrong, guys. From here, they are asking you to calculate the thermal energy, which is obviously your Q, right? Then, in order to find Q, you need to have Q equals to MC theta. You need 3 components to find it, right? You need the mass, you need the specific velocity, you need the change in temperature. A lot of you guys saw this and put this as the change in temperature. Guys, change in temperature should be from a certain temperature to another temperature, right? Unless in this question here, it says that the change in temperature was 100 degrees Celsius. But in this case, it wasn't lah, right? In fact, it started off with saying that it was 19 degrees Celsius. I think Xinyan, you got this one wrong, right? You put 100 here, right? I think it was you. So from here, your temperature was actually supposed to be 100 minus 19. Right? Then after that, specific capacity is this long. Then after that, I'm still missing the mass component. Which I have the volume and I have the density. From here, I should remember that density is equals to mass over volume. Right? And if I want to find mass, it's naturally density multiplied by volume lah. Which in this case here will be 1 multiplied by 1,700. But this is not the final answer also. Because whatever mass that you get, that will be in grams. Right? I want my mass in kg. So I have to divide this with 1,000 and I'll get 1.7 multiplied by 4,200 multiplied by...
I put wrong thoughts on.
But luckily your calculation is correct.
So it's just the unit thoughts on.
Yes, be careful with that. Okay, so from here, I think you end up with 5, 7, 8, 3, 2. You get a raw number, a raw number which you will use later on. The raw number would have been 578,340, which you put into 3 significant figures would have been 578,000 joules. Right. Now, when you calculate the numbers based on your previous numbers, you should always use the raw number and not the rounded off number, guys. From here, you're supposed to use that efficiency. You're supposed to remember the formula efficiency is equals to output over input multiplied by 100%. Right? And in this case here, your output was 578,340 divided by your input, which was 6,300,000. 630,123. Right? Then you multiply by 100%. Based on what you written, you will get somewhere around 91 or 92%. You'll get somewhere around 92%. But I want to emphasize again, guys, when you take numbers carry forward, you should not use the rounded off number. You should use the raw number and then you place it here. Do not use the rounded number, because if let's say you're unlucky, you'll get a totally different answer. Like maybe you'll get 93% or you'll get 91%, which to my understanding you'll be wrong, because they only accept up to 2 significant figures. Right. So if you have like 93 or 91%, you're wrong already. Right. Be careful with that, guys. Very important. I've said this multiple times already. Oh, and speaking of multiple times, I've also mentioned this a lot of times. It's supposed to be 3 significant figures. Xinyan, you were one of them also, right? Always giving me answer in non-3 significant figure. You either learn it now or later in your exam, you lose marks, then you learn it there. If not, if you don't learn it there also, it's never mind. You could learn it in the real IGs also. Always, I've said this multiple times in class, it should be 3 significant figures answer, no matter what. Then this question is definitely worth highlighting as well. In fact, I've mentioned how to explain momentum in terms of pressure already. I told you, you need to remember the 2 formulas, right? For this one, what are the 2 formulas again? That's what I wrote to you, right? Explain to me again how to do this. I'll give you the start. As the air molecules collide against the wall.
The momentum. The
碎佢包聽好你啦。
the mass force.
Okay, 不要講啦，聽我講。Hey, you guys are supposed to remember this. The only way to relate momentum and pressure, you ask yourself, pressure, what formula is it? Pressure is equal to force over area, right? So from here, force or area can be related to momentum. Only force can be related to momentum, right? Because we know for a fact that impulse is Ft equals to mv minus mu, right? So if I want to find force, it's basically the rate of change of momentum, right? Guys, try to understand this theory. Don't memorize it. You think about it this way. If you can remember this formula and this formula here, right? You think about it. If today I have one air molecule here, okay, or gas molecule, or whatever it is, it collides against the walls of the container. When it collides against the wall of the container, it changes direction, right? And because momentum is a vector quantity, it means to say it has magnitude and direction, right? So you're supposed to say something like, as the gas molecules collide against the wall, this increases the rate of change of momentum, which increases the force per unit area of the cylinder, ultimately increasing the pressure. I repeat again, you need to know the concept, then you can bullshit your way through, guys. You're supposed to say that the gas molecule collides against the walls of the container. This increase in change of momentum, or you could say increase of the rate of change of momentum, increases the force per unit area, ultimately increasing the pressure. These are the keywords that I want to see. Definitely collision against the wall, definitely increase in change in momentum, and definitely the increase in force per unit area. These are the three keywords that is supposed to give you your marks, guys. So you can really write anything, but if you want to write as the gas, is it molecules or yeah? One more pro tip, guys. If you see this word here, if the question say molecules, you better write molecules. If they write particles here, you better write particles here also. It's a pro tip. If not, you're wrong. Gas molecules collide against the walls of the cylinder. This increases the rate of change of the something along those lines. Oh, guys, I also want to mention, guys, next week is somewhat in line with Hari Raya holiday, guys. So we will be cancelling next week's class. It will be replaced in the form of extra class sometime later. Okay, guys. I repeat, next week no class. Don't come. Don't come. It will be replaced in the form of extra class sometime in the future. Please make sure you remember this. This question here actually comes up a lot in your exam, guys. You need to be able to remember the formula here, right? And then you bullshit your way through based on how your understanding of the formula is. Okay. Then I think everyone got this correct, so I'm not going to go through this. This one here I want to highlight a little bit. This one here, I've said it before, right? In fact, I think we did something similar in the exercises before as well. When you have all these diagram questions, which has clearly all these different labels here, I've said, you need to actually write everything from the label.
See, it's just 1, 2, 3, 4.
Yes, and you're supposed to explain a few more things, right? So some of you guys may ask me, hey, how come only got 4 labels, but there's 5 marks here? I've told you this before multiple times. Don't care about the marks right now, whatever you know, because most of the time, I'll say this again, they'll structure the question first, then only they'll distribute the marks. Sometimes they realize that, hey, shit, all these questions that I structure doesn't meet the full 80 marks that I'm supposed to have in paper 4. So what they do is they'll add one more mark here, add one more mark here, and so on and so on. So you don't have to care about the marks. You need to write what you know. Okay, then most of the time, a lot of the marks, they're actually intertwined in one word. So for one sentence, you could possibly get 2 marks. You can check the mark scheme later on when we do the past year papers when you're in year 11. But for now, ignore the marks, understand the concept, write down what you know is more important. Okay, so from here, if I look at this question, they say, what do they want? Explain how the label feature of the vacuum flask keeps the liquid by reducing thermal energy transfer. There's only 3 forms of thermal energy transfer, right? Maybe 4 lah. Okay, the first one is known as radiation, convection, okay, evaporation, and then last one. Yes, conduction. We just did it just now, right or not? This one here is basically conduction, right? Convection, convection, radiation, and also evaporation. Either one of these are going to transfer heat only, right? So you should base your answer on these kind of information here, right? Which in this case here, you're going to say, the stopper here prevents heat loss due to evaporation or convection. Silver surface is a poor emitter of heat and a good reflector of heat, so no heat or no heat can escape or enter, right? Vacuum doesn't allow for conduction or convection to occur because both of them needs a medium to transfer heat. And then lastly, you say that glass is a good insulator of heat. It traps the heat inside or it prevents heat from going inwards. Right, so you write all these things down, you'll get your marks already. Right, and if you are uncertain, you can literally just write whatever you know. So for me, I'll write something like this. I'll start with the stopper first. I'll say something like, the stopper prevents heat from escaping due to convection and evaporation. Right, this is definitely going to be 1 mark. Then I say silver surface. Most likely this is where you get your second and third. Silver surfaces are good reflectors of heat and poor emitters and absorbers of heat. It prevents heat from escaping due to radiation. This is your second one. And after that, your third one is going to be the vacuum, right? Vacuum prevents heat from escaping. This is something that prevents conduction and convection to occur, as both of them require a medium. It doesn't have to be word by word, literally anything you need to know. You know, glass is a good insulator of heat. It prevents heat from escaping. Something along these lines now. Literally write down whatever you know, then you most likely get your marks. For those who didn't get a full 5 marks here, copy this down. I think who got a full 5 marks here? Did anyone get a full 5 marks from this question? Yeah, what, anyone of you guys with full 5 marks? Okay. Oh, she didn't got a full 5. Nice. Okay, and then the final one here. Suitable material for this stopper. For some reason, some of you guys dare to write metal. It's definitely not supposed to be a metal, right? It's supposed to be some form of insulator, right? Which would be, what form of insulator would that be?
Plastic.
Or plastic, rubber, wood, anything like literally anything.
Except metal.
Except for metal. Anything else. Okay. Then this final question here also. Most of you guys were able to answer these two, which I only mentioned in class 1,000 times, right? Boiling occurs at boiling point, evaporation occurs at any temperature, boiling occurs throughout the surface, evaporation only occurs. What? Boiling occurs throughout the liquid, evaporation only occurs on the surface, boiling produces bubbles, evaporation does not, or something along these lines. I think most of you guys got this one correct. But most of you guys got this one wrong though. Same for the other classes. You know that if you explain evaporation here in this scenario, you will have gotten your marks already. Like,
I got a 1.
yes, because you only wrote one keyword down only. Yeah, you wrote the more energetic molecules escape. That is one of the keywords.
And then I wrote.
The molecules with lower energy will gain energy and eventually evaporate to the air and process repeatedly. And that's not a keyword. Obviously, that's the case, right? But that's not a keyword, right? So what are a few keywords that you're supposed to mention here? Definitely, number one, you're supposed to say that the heat from the patient's skin is transferred to the molecules on the surface, right? Then you're supposed to mention that the surface molecules will gain energy, break the bonds, and escape to the surrounding as escape to the surrounding as gas molecules. So the more energetic molecules have left, remainers are the less energetic molecules which have less energy, and thus it feels cooler, right? So these are all the keywords that you're supposed to mention now.
I did. Gain energy.
No, you already wrote this: gain energy and escape to the surrounding.
No, I think.
Yes, the ones that have more energy and the ones that gain energy is the same point.
It's like gain like from the gain.
No, it doesn't work that way, Macy. Okay, so you literally the whole evaporation process, right? So you say, energy from the patient's skin is absorbed to overcome the forces of action. And this speed use something along these lines.
Is the boba open yet?
It's too late to order the boba already. It will take more than half an hour. 下次啦，有钱一定有还的，OK。
Gilbert 欠了很久了。
Gilbert 我会欠年久的，是今天下礼拜，不然他今天就给你。下个月，因为下个礼拜没有办法算。 Yes. Okay, run. Okay, everyone. So, final question here. Who's got the hairs for our class? Who else could it be? It should be none other than Xin Yuan once again, right? Xin Yuan, how much do you get? Let me
Yeah,
check.
the overall score of everyone.
Xin Yuan scored 87%. Evan scored 76%. We scored 74%. Hey, Evan was how much, man? 76. Not too bad, everyone. Definitely showed some signs of improvement. But I think the other class, someone's got 90%. The Saturday class. Everett, I think Everett scored 90%.
Who else?
I think Chijun also, Chijun and Howden, I think scored.
Is there Ian in your class?
Yeah, he was absent on the exam day.
Chongyan?
For me, I think yeah, Evan was on a really bad start. But your paper 4 questions were quite good, so it saved you from failing. But your paper 2 is very bad.
Very bad.
Okay, and the last one here, gas can be compressed, but liquids are incompressible. Actually, in terms of molecules, why liquids are incompressible? This is simply because of the structure, right? Gas molecules have very weak forces of attraction, so they are very far apart. There's a lot of space in between them to be compressed. But for liquid molecules, their molecules are already touching each other. Although they can slide past each other, but they cannot be compressed because there is already space in between them. Right, so we're supposed to literally say everything I've just mentioned. Gas molecules have weak forces of attraction. There is space between molecules. The molecules have stronger forces. Space. Anything along these lines.
Why is that turning blue black?
有仪式感，
啊，
有
很痛哎。
啊，整个脚痛。
Like 我只可以 flat 我这样子的。
Oh my god！
他早很就痛了。什么？不痛了
你脚已经变。
因为那是中医，他讲，就你的脚这样像你压着，那会。
快快。Okay, all right, everyone. Anyone else got any question or with regards to this paper? For sure.
After this is wave physics, right?
Yep, that's right. It's wave time. Okay, so if there's no questions, everyone, please bring up your notebook. And then let's continue to the next chapter of waves. Okay.
我们现在很快耶，来快到我的学校哦，很多全部都很吵。
你学校到哪里了？现在？
我们假期，然后又 PVC，然后又有那种 practice sister practice 什么鬼哦，整上个星期完全没有上课。
So are you still in the heat chapter？你们学了 MC data 了吗？哈，到现在还没有学 MC data。
For us, you just finished wave.
Oh, okay, for Evan, okay. Shinian, which chapter are you? Evan, you finished the whole wave chapter already.
I think so. I think I was like maybe one more subtopic, but I'm not sure. Because we ended at light.
Yeah, the wave chapter will comprise of water wave, light waves, a lens, electromagnetic wave, and sound.
Oh yeah, we did all 5 of them.
Oh, then you're done with the chapter.
But then what's after that?
Electricity. Yeah, but your school is going a bit too fast. I feel like I think my pace is going to finish when you guys finish year 11, year 10, then go into year 11. I'll probably pick up the pace a little bit. Not really also. Yeah, probably a little bit so that we have more time to do past year papers.
Also, just want to say my report card will come out on the 26th. I'll just tell you then when I get my physics mark card. Okay, let me know how much you get. Okay, and a 10 pass, you do. But not when you're sick, no. Okay, anyways, everyone pay attention here. This is basically going to be the wave chapter that we're going to be learning. In this wave chapter, there's going to be a few things you definitely need to know. First and foremost, you need to know how a transverse wave looks like. Right, you need to know the key components of a transverse wave, mainly the amplitude, the crest, otherwise known as the peak, the trough, the wavelength, and yeah, what each and every one thing is responsible for. We'll go more in detail about this later on. Then you need to know the formula. This is one of the very few formulas in wave chapter. There's not a lot of formulas. This is basically the speed of the wave formula, which is V equals to F lambda.
Lambda.
V equals to F lambda. Lambda is a symbol for wavelength. Okay, you're going to hear me say it a lot of times. It's very important. It will explain a lot of phenomena if you understand this formula. Please make sure you remember it later on. Then after that, we're going to learn about how we differentiate a longitudinal wave with a transverse wave based on its motion of vibration and also motion of travel, right? Then you need to know that in terms of longitudinal waves, all waves are transverse except for sound and ultrasound. Okay, so if you think about it, makes sense. Sound is definitely a longitudinal wave, right? Everyone should know this by now, right? At least I hope everyone knows this by now. Any other wave that they ask you besides sound and ultrasound, for sure is going to be a transverse wave. Okay, we'll go more in detail about this later on. Then this is the highlight of this chapter here, which we'll most likely not be able to finish. I'm not even sure if we have time to finish. Anyways, these 3 phenomena are basically reflection, refraction, and diffraction. These 3 phenomena are very, very important because they are always going to test your understanding of wave based on either one of these 3 phenomena. So everything else was like a prerequisite to understand this only. Okay. Then reflection of wave is very straightforward. It literally behaves like how a mirror is, right? The light comes in and bounces off. Then refraction is basically like the reason why your straw looks bended in your drink, right? Is because there is a change in speed of the wave. Remember, guys, this is a very important keyword. Refraction happens because there is a change in speed of the wave.
I thought 那个 straw 是以光的折射。
Yeah, which is due to the change in speed of the wave. I'll explain more about this in detail later on. Then after that is going to be this very annoying part, which students always have a very hard time remembering. It's basically the diffraction of wave. Diffraction of wave is the spreading of the wave. You're going to hear me say like Wi-Fi, which this here looks like Wi-Fi, right? And the retarded Wi-Fi, which is this one here. You're going to hear me say this a lot. So I'm always going to ask you guys like, is it going to have a Wi-Fi or is it going to have a retarded Wi-Fi? And you better answer me correctly. If not, I'll be leaving. Right. And then, yeah, everything else will go there. So, okay, so without further ado, let's go into the basic understanding of a transverse wave first. Now, if we talk about transverse wave, obviously I hope everyone once again knows what a transverse wave looks like. For those who do not know, it basically looks something like this. It basically looks like a sine graph right here. Okay, it basically looks like a sine graph. A few things that you definitely need to know in terms of a transverse wave is the first point here, your equilibrium. You can imagine this equilibrium like your x-axis.
but it's known as the equilibrium lah. Okay, it's known as the equilibrium, which is basically the resting part of the wave lah. Okay, not really important. This one is just a reference point. The second part you need to know, which is relatively important, is this one here. From the equilibrium to the peak or the equilibrium to the trough, this is what we call the amplitude of the wave. Amplitude of the wave, okay, is usually measured in meters, right? It tells us the height of the peak, or it tells us the depth of the trough. Okay, so like I mentioned, maybe I should say this first. This part here is known as the peak, or a second name for it is known as the crest. Whichever way you want to remember it, it's the same thing. This one here has a very weird name, which until today, I don't know if I'm pronouncing this correct. It's known as the trough, right? Which is essentially the lowest part of the wave. Okay? Peak, crest, amplitude, trough, and also the final part, which is going to be the wavelength. Now pay attention when I talk about the wavelength now, because for some reason, some students have a very hard time understanding what the wavelength is now. I don't know why. Some students will tell me that here to here is one wavelength, which it bothers me a little bit, man. Like, what happened to mathematics? Didn't you learn some form of maths in it when you were younger? Guys, let me say this, when you talk about wavelength, right, is wavelength, the most layman way I can think about a wavelength is basically when it starts repeating itself. Okay, let's say, for example, I start from the equilibrium position. Okay, it goes up, down, down, up, repeat. Up, down, down, up, repeat. Right, so in other words, here to here is considered one wavelength, right? Right, or here to here is also considered one wavelength. If you tell me that for some godforsaken reason, starting from here, up, down, repeat, down, up, repeat, up, down, repeat, then down, up, repeat. That sounds a bit, you know what it means, right? It doesn't make sense, right, guys? So remember, guys, in a super layman term, and in fact, this will be essential when you do the longitudinal waves also. It's always as soon as it starts repeating itself. Meaning to say, if I start from the equilibrium, it will end at the equilibrium. If I start from the peak, it will end at the peak. This is considered one wavelength. If I start at the trough, it will end at the trough. This is also considered one wavelength. Okay, our wavelength is also measured in meters. Anyone has any questions for this part? Okay, everyone has no questions. Then we look at this part here, guys. This part here is basically the myth that Stephen Chow has lied to us all our lives. You know who Stephen Chow is?
周星。
对，就是周星驰了。你know周星驰有一个戏叫《功夫 Hustle》啊？
很像有看。
是不是？《功夫 Hustle》里面有一个大巫婆，还有一个 skill 叫 The Lion's Roar，right？ 他是everything's time long right? That's impossible, physically impossible.
It's called movie for a reason.
Yeah, I mean, yeah, it's impossible. But anyways, the reason why it's impossible is because if you look at the definition of a wave, guys, it is a transference of energy through space or object, but it does not move the particle. What do I mean by that? It means to say today, if I'm at one side of the door, right, and I'm shouting for you, "Oi, what happens is, right, the energy is passed on from the air, vibrate through this door and pass on to you, right? But this door is definitely not going to move, no matter how I shout at it.
But why
Right.
does a glass break when you shout high?
Very good question. You see all the opera singers, they can always and break the glass, right? The only reason why they can break the glass is because opera singers, they know how to tune their voice to a certain frequency. Do you know that every object in the world has its own vibrating frequency? We call it the resonant frequency. Let's say, for example, today, this glass bottle, imagine it's a glass bottle. Let's say this glass bottle, right, has a resonant frequency of 1000 hertz.
It's meaning to say, without me touching this glass bottle here, it itself is vibrating at 100,000 hertz already. This is what we call resonant frequency, but it's not in your syllabus. It's just good to know only. Okay, so let's say for example, this glass bottle here is resonating at 1,000 hertz. Okay, in order for me to break this glass bottle, I, as an opera singer, have to sing or shout at this thing at its resonant frequency. So I'm like, until it right? What happens is, right, because the resonant frequency is like fist punching into fist, you know. Right, so when I keep singing into it, and then it's also vibrating, eventually it will break itself on. So the glass will actually smash into 1,000 pieces. Because opera singers know how to tune their voice to the resonant frequency.
Wait, so does the glass have a low resonant frequency?
No, it has a high resonant frequency. That's why not a lot of people can do it. So yeah, actually, not only do you have to match the correct frequency, you have to sing it at a prolonged period of time. So like, for example, maybe like 5 or 10 seconds of that resonant frequency, then it will crack. It won't break. I don't think it will break. It will crack unless the bottle. Impossible it will crack. It will break. Most likely it will just crack. Okay, so that's the understanding of resonant frequency. But once again, I want to say that the energy is transferred, but the particles do not move. As you can see here, energy moving from one particle of the door to another, but the door itself has not moved. None of its particles have changed position, no matter how I shout at it. So you know, like everything's on fire. Then you can become Superman already. But if you do not, then most likely physics point of view, it doesn't make sense. Okay. So the particles vibrate or no? Yes, they do. In fact, I just said they vibrate at resonant frequency. Every item in the world has its own resonant frequency.
So like the planet is vibrating now.
Yeah, but we can't see it. Unless you are Ant-Man.
Are we
Then you
vibrating?
shrink, for sure. For sure. Everything vibrates. Unless you reach absolute zero.
Like you died?
No, absolute zero, like 0 Kelvin is what you learned in thermodynamics last time.
Then you died particle.
Technically yes.
Huh?
Yes, technically yes, because only objects at zero, at absolute zero, only objects at absolute zero, like 0 Kelvin, no?
东西是
很难啊, it's quite hard to achieve actually. You have to do a lot of things to make it reach, but unless the object is at absolute zero, if not, for sure, it's just like, for example, if you think about it, why dinosaurs can turn into fossil fuel? Because they still have their energy stored in them, right? And after millions and millions of years, that stored energy becomes fossil fuel, which you use to burn the furnace and everything, right? So unless you reach absolute zero, for sure the particles will be vibrating. Okay. So having said that, copy everything down here and draw the graph.
Is this how you draw in
It doesn't matter, but it's the root 字 in Chinese.
the
You know, like okay, then.
You know, I figured out why people 说可以好到你，因为 people 2找不到网上，因为 it makes sense。people 2找到 people 2你打一下，right? Yes. Don't tell me. 哦，你懂我学校啊，有一个18岁的人呢，在我的1、2。
Okay, guys. Anyways, next thing I want to talk about, guys, which is the important part here, guys. Pay attention now. This here, right, is basically explaining what each and every one of the parts represent now. Starting off with the amplitude, by definition, is what I've mentioned just now also, is the maximum displacement from the equilibrium position now. Meaning to say it could either be the height of the crest, or it could be the depth of the trough measured from the rest position, which is the equilibrium position now. It tells you the loudness if it is a sound wave, guys. So what do I mean by that? If let's say, for example, today I have a wave that has a relatively higher amplitude. Let's say, for example, it goes like this. Okay. then this sound is definitely supposed to be louder
high
with us. But just now I mentioned, right, sound wave by right should be a longitudinal wave. So how come a transverse wave with a higher amplitude will be a louder sound? What does that mean? I'll let you know what, guys. Do you know that all this transverse wave is most likely a digital representation? So most likely, right, if you think about it, today, if you're at the karaoke room, you have a microphone, your sound will be sang into the microphone. But this microphone will transmit data, right? It can't just transmit the longitudinal wave. So what it does is it will convert it into electrical signals, which is most likely going to be a transverse wave. Okay? Meaning to say, if you ever watch those recording equipments before, when you shout very loud, right, the thing will spike even higher, right? The thing will spike even higher. Or when you talk very soft, the recorded sound will be much lower here, right? So all these are basically digital representation of your longitudinal waves, you know. Most likely, because we know for a fact that sound wave is a longitudinal wave, so all these things here are just digital representation of your sound, okay, which works in the karaoke also lah. If you ever been to a karaoke, when you shout them loud into the microphone, the thing spikes up one right? Every time.
got the
But one sound mixer, for sure. When you shout them loud, it goes from green into yellow into orange into red, right? That thing right? That's the digital representation of what's happening here. Even Zoom here also, if you click on the participation, right? You see like my microphone is spiking up and down, right? This is also a representation. It's a representation, right? If I don't speak, it will not move. I mean, it's but it's just a representation only. Okay, so from here you need to know, guys, every time you see the word amplitude, I want you to associate it to the loudness of the sound, and it will definitely be measured in meters. Very, very important. Okay, for wavelength, it is the shortest distance. Wait, pay attention. It is the shortest distance between 2 points in the wave that are in phase. For example, equilibrium to equilibrium, peak to peak, or trial to trial. Okay, for longitudinal waves, it is the distance between two successive compression or rarefactions. For longitudinal waves, they have two parts known as known as compression and known as rarefaction of the wave. Okay, if I want to talk about wavelength, it is compression to compression or is rarefaction to rarefaction. Okay, either one will be. And the SI units are measured in this. Okay, then for period is always associated with time. Like the most common thing for period is basically Riemann period, right? Which is associated as once a month. It's a full cycle, that's why I call it a period. Okay, in physics, period, guys, is basically one full complete wave. The time taken for one full complete wave. Okay, for example, if I look at this diagram here, how many waves are there here? There's 3 waves, right? Let's just say, for example, I say that the total time taken for 3 waves is 9 seconds. How much is the period of this wave?
27.
Huh? I will repeat by definition.
3.
Yes, it should be 3, right? Because 3 seconds was the time taken to complete one full wave, right? So always remember, period is measured in time. And because it is measured in time, right, you should be given the formula as total time taken over number of oscillations, which in this case here will be 9 seconds over 3 oscillations, which gives you 3 seconds here. Some students, they're damn dumb. I don't know why. I hope you're not one of them. Pray to Jesus, right? So from here, like some of them, they'll tell me that it's number of oscillation over time taken, which doesn't make sense, right? Because the fundamental understanding is that period is the time taken, right? It's the time taken. You wouldn't say that, oh, this month I had 2 periods. You won't say that, right? You won't say that, but you say that, oh, period comes once a month, which is measured in time by definition. right? So from here, if you put number of, unless you can have 2 or 3 periods a month, right? If not, this will never be a formula, right? So by right, it should be time over number of oscillation, which in this case here will be 9 seconds divided by 3, which will give you 3 seconds here. Okay, think about the things that is relatable in real life. Then you ask yourself the right questions, it will be easier to understand. Don't keep like, memorize the formula, blah, 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 blah. If you memorize, I can tell you almost no one will remember everything for sure. Relate it to the things that you know. Okay, so from here, by definition, period is the time taken for one point of the wave to complete one oscillation. Okay, in a very simplified statement, period is the time taken to complete one oscillation. Okay, period is the time taken to complete one oscillation. Okay, then after that, we go into frequency, which is what we mentioned just now. Frequency is the reason why the glass can break now, right? Just now we said that each and every one of these items, they have a resonant frequency. Okay, glass has a low, I would assume that glass has relatively lower resonant frequency, so it's easier to break down. Like if I shout at this phone, right, no matter how I shout, it's not going to crack down. I know that for a fact, right? That for sure, and also the fact that this I know has a relatively higher resonant frequency, so it's harder for people to crack it based on singing or shouting at it. Okay, but anyways, that's not the important part. The important part is the definition. Okay, by definition, guys, pay attention to this. You need to understand this. Frequency is the number of complete waves per second. What do I mean by that? Let's say, for example, I have one wave that has 100 hertz versus another wave that has 200 hertz. The difference is that this wave will complete 100 oscillations in 1 second, whereas this wave here will complete 200 oscillations in 1 second. Okay, so it is the number of complete waves produced per second. This is what frequency is. Okay, the higher the frequency, the higher the oscillations per second. Okay, obviously frequency is measured in hertz, and frequency relates to the pitch of the sound. The higher the frequency, definitely the higher the pitch. Okay, in general, men are very lazy creatures. That's why when they talk, their voice box oscillate at a much lower frequency. That's why you don't hear a high pitch. But women are more kanjiang one, right? No, it's because of the pitch of the. It's the voice box oscillation. The reason why we have sound is because we have voice box that are oscillating, right? Then our tongue and our mouth will adjust the way the sound comes out. That's why we have different pronunciations and everything, right? That's why our mouth must move on. Okay, but anyways, think about it this way: men are lazy creatures. That's a known fact, right? That's a known fact. That's why our voice is relatively lower, and we are more deeper, manly voice one because our oscillation is low. But women a bit more kanjiang one. Okay, they're for sure a bit more kanjiang. So when they talk, right, their voice box oscillate faster, right? And thus they have a higher pitch because they have more frequency in the sound. Okay, this is like one way to remember it. So that one. Okay, so there is also one simple formula, but this is not the only formula. Frequency is 1 over period. Okay, let's say for example, I say that just now the period was 3 seconds, right? It means to say the frequency of this wave is 1 over 3, which is 0.33 hertz. What does 0.33 hertz means? Just now I said 100 hertz means to say there's 100 oscillations per second, right? 0.33 hertz means to say that there's only 1/3 of the oscillation per second, which makes sense because if you look back here, right? Here, somewhere around here will be 2 seconds, somewhere around here will be 1 second, right? This one here is only 0.33 or 0.33. What? No wonder my writing is so ugly. It always auto corrects. You see that? 0.33 hertz or 1/3 of the wave only. So if I say I have 0.33 hertz, it means to say in 1 second, I can only complete 1/3 of the oscillation. You understand? Makes sense? Okay. Please copy everything down.
Hey everybody! One last thing before we end the day, which is the formula here. Now, the given formula for speed of wave is known as V equals to F lambda. Now, we know for a fact, guys, we know for a fact that speed is equals to V equals to F lambda. But by definition, our frequency is measured in hertz. Wavelength is measured in meters. Why wouldn't the units be hertz meter here? Why is it still going to be meters per second instead for the speed? Why?
Because speed is meter per second.
Okay, but here hertz multiplied by meters. Well, why did we change it into meters per second, not hertz meter?
Because hertz is counting with hertz per second.
Very good. Because by very definition, frequency is 1 over period, which is by definition 1 over second. So in other words, 1 over second, the derived units is supposed to be hertz. So in reality, this is actually 1 over second multiplying with meters, which will once again give you meters per second at the end of the day. You understand? This formula calculates the speed of the wave, meaning to say, the higher the frequency of the wave, the higher the speed, the larger the wavelength of the wave, the higher the speed also. Understand? Copy this down. And then do everything else. All the 8 questions at the bottom. That's going to be it for today. Okay, guys, I'm gonna end class here today. I want you all to finish everything like question 1 to 8 as your homework, guys. And reminder again, next week we'll be cancelling class in conjunction with Hari Raya. Please don't come to the center. We'll replace it in the form of extra class.
跟我讲了 holiday
Okay? I'll see you all next week. Goodbye.
Should I go see it?